How are you? I hope this finds you well. So today I want us to go through another topic on epidemiological methods of methods that are normally used to gather data, to analyze the data, and as well as to interpret and report the data that have already been analyzed. So in a lot of studies, so epidemiology involves a lot of study, different types of study, or different ways through which researchers or epidemiologists can use in order to solve some of the problems that are normally experienced, or health problems that are normally experienced in our community. So these methods are what I'm calling here as epidemiological methods. And these are the various approaches in which data is gathered, analyzed, and reports written with regard to the various diseases in terms of distribution as well as determinants. So they enable us to plan and evaluate disease management in communities. They will help us to know the extent of the disease, what is causing this disease, and by that, it will help us to plan as well as evaluate the disease management in our community, to know how the disease management is helping to elevate these diseases from our community. Then there are several methods in which they are classified in the following ways. So we have descriptive methods, we have analytical studies, we have experimental studies, as well as we have community-based studies. So we'll go one after the other and see what kind of methods are normally used in these types of studies, and how do these studies help to solve the problems in our community. So the first study is descriptive studies, and these are basic studies that seek to describe the situation as it is. The way the situation is, the current situation, and the way the situation represents itself currently or at this time, at that moment, to study those situation at that moment, we use descriptive studies. We don't follow to know what will happen in future, or we don't look backward to know what caused the things that are happening now. So we are studying the situation as it is. So these methods utilizes simple descriptive statistics such as percentages, tables, and graphs to describe the disease situation. So these studies normally generate hypotheses. They don't completely solve the situation. They help us to know how is the situation, and then maybe other studies can come to analyze more about the situation. So the descriptive studies normally helps to generate a hypothesis. For example, a hypothesis can be men are more, or cardiovascular diseases are more experienced in men as compared to female. That is a hypothesis. Or women are more, or there are more women with the disease as compared to men. That is also a hypothesis, because you are studying the situation as it is. You're not analyzing further to know deeper causes of this disease. You're just studying the disease as it is. Examples of descriptive studies, we have individual-based studies, and this type of studies normally reflect on a single individual as a unit of the study. So you're studying the individual singularly as a unit of study. You're not studying them as a whole, as a community. You're just dealing with individuals. And this can either be a case report, where a single unique case is reported as it is identified by a health worker. For example, there might be a funny disease that have never been experienced in a hospital or in a location. Then it represents itself in the hospital. So it's upon the health worker to notify the epidemiologist that we are having a unique disease that have never been experienced elsewhere, and then epidemiologists to study the disease that have been represented. Remember, we are dealing with a single individual here. Then we have case series, where reports that have similar characteristics are analyzed so as to draw conclusion in relation to the particular disease of interest. So when we are dealing with case series, we are dealing with several reports or that have been reported which have similar characteristics as analyzed so as to draw conclusion in relation to the particular disease of interest. For example, coronavirus. You might have, wherever it came from or wherever it is originated from, there were several reports, one individual after the other, and those individuals represented with similar characteristics. So it's upon the epidemiologist in that place or in that region to look at these cases individually and also make conclusions after they have analyzed these individuals singularly or as a unit. So those are the two types of individual-based studies. We have case reports when you're dealing with one single case, and we have several case reports or case series when you're dealing with several cases that are representing with similar characteristics or with similar symptoms and signs. Then another type of descriptive studies, population-based studies, and this includes surveys. It also includes cross-sectional studies, and surveys are conducted over a short duration of time with specific objectives. For example, if you want to do a survey to identify the usage of mask in Roido town, that will be a survey, because you're doing that maybe in a day or 2 days, and you have a specific objective. I want to know the percentage of people using masks, the percentage of use of shops that are instructing their customers to wash their hands before they enter the shop. So you have specific objectives, and that is done at over a short duration of time. There are more fact-finding studies in a bid to rapidly draw conclusion with regard to illness or conditions affecting the entire population. For example, if we have a lot of people suffering from corona in Redo town, you would want to know what is really contributing to the high number of cases being represented in Roilo. So you'll go and look for facts. Are they using masks? Are they supposed to be? Are they sanitizing? Are they hand washing before they do anything? So what about the social distancing? Are people observing the social distancing rule or guidelines? So they are more fact finding in a bid to rapidly draw conclusion with regard to an illness. That is survey. Then we have another type of population-based studies. And remember, here we are dealing with many people. We are dealing with a population. So cross-sectional studies are studies carried out across a huge population sample over a very short duration of time. So these are studies that are normally carried across a huge population over a short duration of time. Their methodology and analysis is more advanced than that of the survey. So for cross-sectional studies, we have more or deeper analysis and more complicated methodology that are advanced as compared to survey. But the two are normally conducted in a similar way. It's only that for surveys, you're doing it at a very short time or within a very short time and with specific objectives. But for cross-sectional studies, they're normally done across a huge sample. So you'll have to take a more time as compared to in surveys. And their methodologies as well as analysis is more advanced as compared to, you'll find in cross-sectional studies, you'll use things like correlation. You'll try to correlate other factors. For example, you try to correlate gender and the use of masks. But for survey, you're just looking at what percentage of women or what percentages of women are using masks, what percentages of men are using masks. But for cross-sectional studies, you'll go deeper and look at, do men correlate, or do gender correlate to the use of mask? Do gender correlate to social distancing? Do genetics, do other factors contribute to the adherence of the guidelines that have been given to overcome coronavirus? So in cross-sectional studies, you have more analysis that is more advanced as compared to in surveys. Then another type of population-based studies, correlation studies, and these studies seek to compare one variable or characteristics of a population with more or with one or more others. For example, a comparison between smoking and lung disease, or immunization coverage and measles outbreaks. One may also compare worm infestation against use of latrines among the household, water, and maternal literacy, etc. So in correlation study, you try to relate independent variables and dependent variables. So you will try to see whether the dependent variables really depend on other factors for them to exist or for them to increase or decrease. You try to correlate, for example, the example given here, you'll try to correlate whether smoking can lead to lung cancer. But remember, you're not following these individuals. You're just looking at, is this person a smoker? And do this person have cancer or lung cancer? So you'll try, after collecting all data and analyzing, you try to look at the correlation or the relationship between the one factor and the other. And by that you're using the dependent variables and independent variables and looking at whether they relate in one way or another. That is descriptive studies. For descriptive studies, you can divide them into two. We have individual-based studies and population-based studies. For individual-based studies, you're dealing with individual as a unit, and you can deal with individual as a unit in two ways. You can do case report when you're dealing with a case that have been reported, for example, by a health worker. A unique case. It's not like malaria, which is not unique. You're dealing with, for example, Ebola. Ebola is a very unique case. Before it was even discovered, whoever discovered it, so reported that as a case report. Then, where we have several cases that have been reported with similar characteristics, that will be case series. And these are under individual-based reports or individual-based studies, sorry. Then for population-based studies, we can have surveys, we can have cross-sectional studies, we can have correlation studies. So for analytical study, the second type of study is analytical studies, and these studies are more advanced in methodology and analysis, and their findings are more generalizable as compared to descriptive studies. Because, for example, you might find Roiro having different cases of coronavirus, or men in Roiro having different percentages as compared to men in Turkana. Because that is, we are just describing the situation as it is, but we are not going deeper to look at the causes of coronavirus, what are the types of the viruses involved here. So for analysis, you're using more methodology as well as advanced analysis. And the results of all that, of your analysis, you will be able to generalize. So the results here of analysis or analytical studies, you can use them in Mombasa, you can use them in wherever place you go, because they have been done a lot of analysis, they have been done a lot of scrutiny, such that you can be able to generalize as compared to the descriptive studies. So while descriptive studies generate hypotheses, this one tests the hypothesis. Because of the advanced analysis, you're able to test the hypotheses that are normally generated in descriptive studies. For example, if I say gender is correlated to, or is positively correlated to coronavirus, that is a hypothesis. So analytical studies will come and look deeper into that hypothesis that I've set in descriptive studies in order to know, is that hypothesis true or not, and either reject or not accept the hypothesis. So the first analytical study is prospective studies, also known as studies. Studies start with individuals with an exposure of interest and who are followed up over time. They are then compared with individuals who do not have the exposure of interest. So we have individuals that have been exposed to, for example, smoking. You follow those 10 people who have been who are smokers for 10 years, but you have to follow concurrently or at the same time another 10 individuals who are not smokers. And after those 10 years, you then determine what percentage of people who are smokers have lung cancer and what percentage of people who are non-smokers have lung cancer. And then you can make conclusion from the differences in those two. So they are then compared with individuals who do not have the exposure of interest. So they are then normally compared with individuals who do not have the exposure of interest. So analysis is then done to find out if those who have exposure will develop the outcome of interest more than those without exposure. For example, when working in a farm exposed to zoonotic diseases are followed up over time to establish if they will manifest the zoonotic diseases over time. Zoonotic diseases are diseases that can be passed from an animal to a human being. So simultaneously, a similar group of individuals who do not work in the farms are followed up to establish if they develop zoonotic diseases. So for example, if you find out that 8 out of 10 who are working in the farms contract, for example, a brucella, because that's a zoonotic disease, brucella diseases. And those who, or individuals who did not work in the farm for those 10 years that were following them up, only 2 developed zoonotic diseases. Then you can make a conclusion that exposure to animals is a risk factor to contracting zoonotic diseases. What happens if the vice versa is true? When you have 10 people who are exposed to zoonotic, to animals, developed the zoonotic diseases, and 2 people from the group that were working in the farm developed the zoonotic diseases, you will find that the 2 is not correlated. You can't make a conclusion that zoonotic diseases are caused by exposure to animals, because after analysis, this will help you to know the correlation between the 2. But this is after following them up. And you have to have 2 groups of people. You have to have a control group and the group that is being exposed to a certain risk factor. So as you can see here, we are trying to test the hypothesis, for example, that is being brought up. Maybe we had a hypothesis that exposure to animals is a risk factor to development of zoonotic diseases or contracting of zoonotic diseases. So when we want to test that, we have to conduct these prospective studies by following up the individuals over a period of time that have been exposed, and also following up individuals who are not exposed to a certain risk factor. Another type of study is retrospective study, also known as case control studies. And these studies are easier to conduct, consume less time as compared to cohort studies. Don't get confused between these two. We have retrospective, which is case control studies, and you have prospective, which is a cohort studies. So in retrospective studies, two groups are selected from a population, one group with the disease of interest and the other without the disease of interest. For example, we can look for 10 people who have lung cancer and look for 10 people who do not have lung cancer. Then you look backward, or you ask by asking them about their past in order to establish if they had a common exposure that might have caused the disease. So when you have a group of people with lung cancer and you have another group of people without the lung cancer, so the first group with the lung cancer, you have to look backward by asking them, have you ever been smoking for the past 10 years? So you might find that maybe all of them have been smoking. Then for the group that do not have the lung cancer, you also ask them the same similar questions. Have you been smoking? You might find that maybe 2 have been smoking for the past 10 years. Then you can make a conclusion that smoking is correlated to lung cancer or contracting lung cancer. But if the vice versa is true, then you can't make a conclusion that smoking is caused by lung cancer, because if there are more smoking and they are less having the cancer, and those with the cancer did not smoke, then there is no any conclusion that you can make from such a data. So these studies are, however, prone to recall biases. Some people may not remember when did I start smoking. Some people may even not remember at all if they've ever maybe been exposed to a certain risk factor. For example, in a community, people who have amoebiasis may be asked about their food, the sources, the preparation, the storage, and consumption. So recall bias will remember, where did I get the food? Maybe they ate in restaurants, then they forgot. The preparation method may also be forgotten, and many other things. So another group from the same community who do not suffer from amoebiasis is asked the same similar questions, and then the data is analyzed and conclusion is made from whatever that is gotten from the two. Another type of study under analytical studies, experimental studies. And these are laboratory setup kind of study. These are studies conducted in a controlled environment where the researcher has control over the variables. For prospective, you're just assuming that they will follow what you want them to follow. For example, you might find there's some people that will drop out, there's some people that will die in the process in the prospective studies. But for this environmental study, you have the control. For example, if you're testing a drug or the effects of maybe coronavirus vaccine, they will use experimental studies to come up with that vaccine. So they will have people that may be in a control environment where they're monitored each and every minute. That is an experimental study, because the researcher or whoever is giving out this vaccine have control over that, the usage of that vaccine. They have total control on how these individuals use the vaccine. You use maybe a supplement if they want to test the effects of a supplement, the use of maybe a drug, and etc. So they are very useful in isolation of the actual disease causative agent. They can also be used to look for what is causing a certain disease. So they are very strict and also very expensive. You need a lot of money to carry out this experimental study. And that's why majority of people will not involve themselves in experimental studies, because they're very and quite expensive. So they require highly specialized personnel and equipment. You need laboratory technician, you need a lot of people, you also need a lot of equipment, which are also very expensive, making this type of this type of studies very expensive. Then another type of study is community trials, and this involves the entire community. An example is, in one community, water may be fluoridated, while in the other, it may not. The two are followed up when, with time, if those taking water that is not fluoridated start complaining of teeth problem, then the effects of fluoride are confirmed. You're following up the entire community, and you have to have two types of community: the one that is exposed to fluoridated water and the one that is not exposed to fluoridated water. For example, that's why they came up with a conclusion that Naivasha water is the cause of high dental caries that are normally experienced by the people living around Lake Naivasha, because Lake Naivasha is highly fluoridated. So you find a lot of people around Lake Naivasha having dental caries or decaying tooth because of the highly fluoridated water. So that community was followed up, and that was exposed to water that is not fluoridated. So those exposed to the fluoridated water, majority of them developed the tooth decay, as compared to those that was not exposed to fluoridated water. So those are the types of epidemiological studies, and we have two. We have descriptive studies and we have analytical studies. And each and every one of them have categories. So what are the importances of epidemiology in communicable disease control? Why do we need epidemiology to control the spread of coronavirus? Why do we need epidemiology to overcome coronavirus, the whole world that is affecting the whole world? So epidemiology is important in communicable disease control because of the following reason. Number one, it enables us to know the disease distribution patterns. Right now, because of the epidemiology that we are having each and every time in Kenya, we're able to know coronavirus is more in Nairobi and in Mombasa as compared to other counties. That is distribution patterns. Coronavirus is more in the slums as compared to other parts of Nairobi County. Another example, or another important, it enables us to know the disease causation factors. What are the factors that are contributing to the causes of coronavirus, or even the spread of the coronavirus? Then it also equips us with data that we can apply for effective prevention and control of the diseases. It enables us, or it equips us with the data that we can apply for effective prevention and control of the disease. It will help us to know, or to have the information that you can use for effective prevention and control of the disease. How do we prevent and how do we control the spread of this disease? Then the fifth importance, it normally enables us to understand the disease progression and what measures need to be taken to halt or reduce disease effects. It will help us to understand how the disease is progressing and what measures can we use in order to make sure that these diseases is stopped from progressing to other parts of the world. Then we also have another importance. It enables us to evaluate intervention programs, the programs that we can intervene in order to overcome this coronavirus. And how do these intervention programs working? Are they working positively or even negatively? So to know that, we have to use epidemiology in order to evaluate that. Then it also enables us to conduct research with regard to communicable diseases and how they affect populations. So we'll also know how this coronavirus is affecting the population by use of this. For example, descriptive studies. You'll ask people, how do the coronavirus how have it affected your family? How have it affected your economic income? How has it affected your normal economic activities that you're normally involved in each and every day? So all these are the importances of epidemiology. It normally helps us to control, it helps us to prevent, it will also help us to know the causes of and the contributing factors to a certain disease. How is disease distributed? How is this disease being spread? And what means can we use, or what interventions can we put in place in order to overcome this spread of this disease? And how do we know that these interventions are working or not? That is evaluation of these interventions. So all these are the importances of epidemiological studies. So this these slides forms the last part of this class. So I hope you have understood, and if in case you don't have you need some clarification on me through the given channels or the usual channels that you normally use. So have a lovely time and all the best. So you can also go through the YouTube videos through the links that I've given in the portal. They will also give you more understanding into the types of epidemiological studies that you normally have in our community. So all the best and God bless you.